Hello, everyone. Welcome to another binary episode of the Day Zero podcast. Before we get into the topics, we'll cover the Spot the Vuln solution for this week. So, Z, I'll let you take that away.
Sorry, was getting some other things working right as you transition. Nice quick. So yeah, Spot the Vuln this week was actually based on a vulnerability from last week's episode, which probably should have had the link up here, but fixing a security bug by changing a function signature. I'll have that link in the description here again, but the main issue here was the fact that this mar insert item function has an integer name length, and then in the memcopy it does the name length plus 1. So when it's calling memcopy, that's going to be converted to an unsigned long value, which means the integer is going to end up being sign extended. It'll basically just take, if the sign bit is flipped, it'll just take that and extend it out. The post for this bug actually goes into a lot of detail over how that works, why it works, or what it does. So I'll leave that as an exercise for you to look into if you want to. But the gist of this one is just because of that separation between using an integer versus using or sending it into a function expecting an unsigned long. Actually, it is probably a size t, but effectively unsigned long. Because of that, it's going to extend it out into a much larger value than it's actually expecting to be. So rather than doing a memcopy of namelen plus 1, it's going to be some very large value, going somewhat close to your 64-bit max.
Basically, the bug here is using C. No, I'm just kidding.
Getting into that discussion.
Yeah, just a joke for referencing that last discussion. But yeah, I mean, sign this is hard. So, but yeah, fairly straightforward bug. Though you did have to kind of the prototype was like the main thing you had to look at there. So
yeah, I will shout out that one thing that is a little bit suspicious, especially if you don't write a lot of C, is the fact that it does the allocation just doing this addition of namelen and a memcopy with namelen plus 1. That distinction of you're adding like a different number, so you might have a off by 1 issue there. A couple people had pointed that one out on Discord. I think even in chat before yesterday's stream might have been pointed out. Fair issue to notice. It's definitely suspicious, but what happens and what's happening in this case is the item structure that's being allocated has the name as the last element, and just like a single byte array. And then they just allocate more space for it so they can use that name as just a kind of generic array. It's a somewhat common pattern to treat that like a flexible buffer at the end of the structure.
Yeah. So, kind of as Z touched on there, for any like future Spot the Vuln challenges or even this one, join our Discord. We always have some fun discussion on Z Spot the Vuln challenges in that channel. So, if you want to get in on that, you can join our Discord for that. All right, so we'll get into some topics here. We'll start off with some lighter news that came out of the EU, which is that no contract can prevent you from decompiling software that you have bought if your goal is fixing a bug. Now, this is paraphrased by Revenge on Twitter. The actual document here is a lot of legal speak and is pretty damn hard to read, if I'm being honest.
I mean, it is, but if you go right to the bottom of it, the actual ruling of the court, so there's a lot of the background what the lower court was actually asking and what their question was. Ultimately, though, like they just have the couple articles at the very end there with what their actual ruling is on this, and effectively, a lawful purchaser of a computer program is entitled to decompile all or part of the program in order to correct errors affecting its operation, including where the correction consists in disabling a function that is affecting the proper operation of the application of which the program forms a part. I mean, that is reasonably distinct and clear as to what what their ruling is. Obviously, they include a lot more of the reasoning and background coming in on the rest of it, but essentially it's a good move for like reverse engineering. At least if you're in the EU. Unfortunately, neither of us are, but if you are there, it's a positive move.
Yeah, I mean, I must say the EU over the last couple of years has done a lot of good in the technology space for like regulations and stuff. I'm a little bit jealous that we're in North America. Like GDPR, as much as it was like all encompassing and kind of a bit vague in some areas, I think overall was a positive move, and this is like another kind of step in that direction. There was something in the background, as you point out, or the legal context that I wanted to point out, just because I saw some discussion in the thread for that tweet. So one person pointed out, like, is there potential loopholes here with something like circumventing DRM, for example? Because someone pointed out, if you can argue a DRM solution causes performance degradation and kind of argue that into the hinders the correct use of the application or whatever, could that allow you to patch it, reverse it, and patch that out legally? Um, One section that I did want to point out is, let me just jump to it here. Yeah. So, like in the section 3 of the legal context, they have provided that these acts do not infringe on the copyright of the program. So I feel like that potential loophole that someone pointed out is covered here, where like
Yeah, and
you
you
can't
would
kind of
expect
argue that
this.
DRM would be a bug because by bypassing the DRM, you are infringing the copyright, right?
Well, kind of. So I don't know EU law, so I am kind of basing this on I have a bit of experience around DMCA in particular because of one of my past projects and needing to get a lawyer involved. Oh, that said, like generally speaking, like a lot of these things don't exempt you from any sort of other law. So even if you were to have the argument of like I need to reverse engineer this and remove DRM because it's just not working on my machine or something in that nature, that's not going to allow you to then go on and distribute that modified version at all. This allows you to do that reverse engineering and do that for yourself. If you were to distribute a copyrighted software and like, with your modifications or like there are still other laws that come into play with that. This is basically saying like they can't, and yeah, I mean, obviously we are always being focused in by the fact that it has to be to fix a bug. No statement about finding bugs through reverse engineering, although I can imagine it would be hard to take that one to court. Obviously, I'm not a lawyer, but
Yeah, the obligatory we're not lawyers when we cover these kinds of stories. This is kind of our layman's perspective on it, I guess, and our like interpretations of it. They might not be correct, but I think the more interesting case that I thought of, like spinning off of the DRM idea, is I wonder if you could go after anti-cheat with this. And the reason I bring that up is there has been more of a shift to the legal pursuit from like game developer companies, especially companies like Blizzard, going after like the major pay to cheat providers. And I wonder if you could have like a legal argument for going after the anti cheat in the context of like performance degradation or a vulnerability that you might find in it. Just because anti
so
cheat doesn't really fall in the same category as like a in the category of copyright, right? So that is kind of an interesting case that I would be interested to see how that plays out, or if that plays out at all. Um, but yeah, I mean, I could see this potentially being abused, but I
I
don't
mean,
think that should take away from the good faith
uh,
of the action.
a lot of it seems to come back around like loopholes to how are you interpreting a bug in the software? As being like is anti-cheat a bug? Is something a bug because it degrades performance or not? And that I don't believe is answered in here. So that
That's what
would
it
need,
comes down to. Yeah.
further rulings to actually decide what is a bug, but I have a feeling that some of those probably wouldn't hold if they were tested in court. But as far as I'm aware, they have not been tested in court.
Yeah. So all we can really do here is like speculate and just give some interpretations of what some loopholes could be of the ruling. But overall, I mean, I think it's a solid move in the right direction. It's kind of following that idea of like the right to repair, except instead of hardware, it's software, right? That's the movement, and right to repair by and large is supported by consumers, or at least it should be. So, um, yeah, overall a good ruling. We'll just have to see if it leads to any loopholes that could be abused. And Brinley, I'm the speaker right now. I'm Spectre is speaking right now. So, yeah. But yeah, unless you have any final thoughts on that, Z, we'll move into some of the more technical topics of our episode. So, Open5GS is our next topic, which has a Stack Overflow in it. Open5GS is an open source implemented 5G core. The issue here is caused when parsing a session establishment request packet in OGS FQDN parse. See if I can. Oh, they don't have a snippet in the article, I don't think. That is one thing with this article. You kind of have to go out of your way to find the like code that it's talking about. But
yeah, and I do have the patch here actually.
Okay, cool. So yeah, basically the function would take an unmitigated length and pass it to memcopy. Pretty straightforward. Z has the patch diff up here. For what it's worth, I looked at the build config, and they do compile with stack protectors. That doesn't necessarily mean this isn't an exploitable bug. You might be able to find something else laying on the stack that you could corrupt to give you a better like memory corruption primitive. In a complex application like this, I'd say that's fairly likely, actually. That said, it's kind of hard to confirm because I did try to do some digging to see if there was anywhere obvious, but the code flow is actually pretty complex. You would have to spend a good deal of time looking to confirm. This is somewhere where something like CodeQL might be able to be leveraged if you actually wanted to try to exploit the issue. But just doing some like manual review, I went up like 4 or 5 calls in the chain from the vulnerable function, and it was still like really tricky to confirm. So, yeah, not saying this issue wouldn't be exploitable, but I did want to point out that it compiles with stack protectors, because that is always notable when you're talking about a Stack Overflow. But yeah, as far as the vulnerability goes, pretty straightforward.
It would somewhat depend on like, are all of the calls actually to this coming off the stack too for the destination source, or well, for the destination variable. Potentially something off the heap. I mean, that really depends on how the function's being used. Because it's just taking in the destination and source pointers. It's not allocating them itself for the Stack Overflow.
I must say, I wish the post here from NCC Group was a little bit more detailed, because basically all they do here is they point out like where the bug is, the files that it affects, and then they have like the Python POC. So they don't really go into any details of like how this could be exploited or the potential paths or anything like that. So that's kind of left to the reader, I guess, if you're interested enough. But at least from their technical advisory, it seems that it's always coming from the stack, given that they like titled it a stack buffer overflow. But I mean, you're right. There could, even in the future, there could be functionality added that ends up using that function for a heap allocation as well. It seems fairly generic, so I could see it being used in that context too. And obviously, if that happens and you can get heap memory corruption, that immediately makes it a lot more interesting from an exploitation perspective. So
yeah, I mean, like stack is nice for the exploitation, ignoring the canaries, at least generally a bit more stable, a little bit. Like if you do have a place where you've got a stack allocated buffer, it's likely to be a bit more consistent than the heap. So, like there are nice things about it being on the stack also. I just wasn't sure about that. I mean, it's just taking pointers in.
Yeah. I did want to pull something out of chat quickly before we move on. Somebody asking about a PS4 WebKit for 8.0. So I think some people are missing some context there. There was a Safari bug that somebody, I think Sakeo, pointed out, but that only impacts Safari. I believe he clarified later on. It doesn't affect the PS4. So, yeah, I did just want to answer that quickly because it seems like there's a lot of people that have been like DMing me today or pinging me about that, and it's like, yeah, there's more to that story that makes it ultimately useless for that. But yeah, with that said, we'll move on to some HyperKit bugs. So this is from GitHub Security Lab. It covers 4 vulnerabilities in HyperKit, which is a core component of Docker for macOS. It's a hypervisor essentially, based on Beehive for lightweight VM and containers. So where this is based on Beehive, one of the issues in here is basically the exact same issue we covered on our binary episode a few weeks ago, or rather about a month ago on the 7th of September. But yeah, let's get into some of the issues. So the first 2 bugs aren't really too interesting. Um, it's a null dereference where various handlers that are available in the virt.io table just don't get initialized in some drivers. They're just left as null. And some areas of code, such as the VC CFG read call in virtio.c, like there's some places where those handlers are called, but they don't actually check if it's a null pointer. So straight up null dereference, not really too interesting there. I think the VT ran device for paravirtualized randomness is one of those areas that doesn't use that or doesn't check that handler. The second bug is very similar to the first one. It's just in the write path instead of the read path. The third bug is the duplicate of what we covered last month. It's in the exact same driver, the VTRND device. For those who weren't around for that episode, basically, there's some areas of code that don't check the return value of VQ get chain, which can fail. And that function is used to populate IOVEX that get used for doing reads and writes into the guest memory. So you can end up populating those IOVEX with your own values through uninitialized memory use, and you can obtain like an arbitrary read write using those. So definitely a lot more impactful than the first 2, but it is basically just an issue in Beehive that ended up propagating to HyperKit. Fourth bug is another uninitialized memory use due to essentially the same thing. It's a variant. This time it's in the PCI VTSOC proc TX. This is one of those cases where they tried to check the return value to ensure that it's less or equal to the number of max segments, but it's not a sufficient check because that can just return -1 as well on failure. They don't check for that, so you have that same impact where uninitialized memory ends up getting used for the IOVEX. So yeah, those issues, nothing super complex there, but yeah, those latter 2 issues are pretty useful from an attacker perspective.
I mean,
And if you
nothing.
want, maybe, oh, go ahead.
Let's say nothing like that complex, as you said, but I mean, check your errors. It's such a common pattern to see just errors not being checked for whatever reason, or not being checked appropriately. As is with issue 3, one of the issues is that places won't check that the return value is what was expected versus just that it was successful.
Yeah, it's such a common issue that it's probably the most common functionality you'll see in like SaaS tools. Like, I don't do a ton of static analysis, but like a few of the tools I've used, one of the first things that you try it out with, or the examples they provide, is looking for unchecked return values because it's such a simple issue, but it's so common, and it can lead to problems. Like error handling in general is just difficult for monolithic applications. So, yeah, the other thing I was going to point out was if you wanted a little bit more on the VQ get chain issue, you can go back to that episode where we covered it in early September. I think that went a little bit more into detail about how this could be, or how that issue could be exploited. So you might just want to refer back to that blog post if you want some more information on that. But yeah, so we do have one final bug in HyperKit. This one is in the disk driver. Z, I don't know if you want to cover this one because I know I've been talking a lot this episode, so
Yeah,
I don't want to steal all the topics.
Fair enough. But yeah, this one I thought is actually kind of the more interesting bug, just because of how it came about. So again, we're dealing with HyperKit again. This time though, the issue is in the PCI VT BLK proc. Handles incoming VirtIO descriptors, and you have the IO operations coming in. One particular IO operations is the VBH op discard, and you can take a look at the code here. The snippet in the very first assert that you see is kind of where you have the bug. Assert IOV1 and then .iov len equals size of whatever. Key thing there, that is an equal sign and not a double equals. So reading the comment, it's saying, they're expecting a correctly sized payload descriptor. So it sounds like what they wanted here is to do a double equals to make sure that the length equals the expected size of the structure. Instead, what they've done is they've assigned the length the value that they want. So that basically can end up with a out of bounds write on the host, reading a little bit of extra memory. Essentially, this assert won't fail or can't really fail. It'll always make that assignment. The assert will always go through, and the IOVAC len will always be that length, regardless of what it should actually be. So I think like just the way that came about, that little typo, I mean, that is where you've got some people will do Yoda conditions, where you'll see this sort of bug every so often. I haven't seen it actually in quite a few years now, but I'm sure it's still floating out there in some code, where they'll do it inside of an if statement, typing a single equals instead of double equals. So yeah, in this case, that's the gist of it. Somebody made a typo and didn't notice it.
Yeah, something we've seen a few times before. I forget exactly what it was last time we covered it, but it might have been like they were trying to do a bitwise operation, and it just, because of the typo, it was like completely opposite of what it was. Actually, it might have been in BPF, come to think of it. It might have been a Linux kernel issue where...
Are you thinking of the...
So sorry, I'm thinking of a slightly different bug.
Yeah, I think
I'm thinking of where they went to shift to the right when they should have shifted to the left.
And calculate the wrong min and max values for the ranges of the BPF registers. Yeah.
Yeah. So kind of similar in the way that it was just like a, getting something switched up when writing the code. Something that's not a like blatant, we didn't think about this, or we didn't think about doing a size check, but more just along the lines of, maybe some tired programming or whatever, right?
Yeah, I mean, this is very easy to do. I'm sure, you write a single equals plenty of times, and you do a double sometimes too. Super easy mistake to make. You've either got to have the eye for it, or you have warnings set up to notice things like that. To notice, and I mean, that is... Yeah, so I was going to say that's a bit of a challenge with the assert, but actually, I mean, asserts... I mean, I've seen it where they're doing an assignment in the assert, but using it kind of because the value will pass through to the assert. So if it's assigning like 0, the assert can catch that.
Yeah.
Because in if statements, it's a lot more obvious, because you should basically never have an assignment happening in an if statement, albeit some people still do it. Same idea, passing it along. It is something that should get warned on, I believe, by compilers anyhow. At least, if you're compiling with all the warnings.
Who reads warnings, though?
Yeah, just ignore them. They're merely suggestions.
Exactly.
I do like this bug, though. Just, it is one of those things that, it's a human writing code. It happens.
Yeah, it's a cool bug. One interesting thing that I wanted to point out, with this issue, and I think some of the last issues that we covered, you can see assert being used quite a bit for the error checks. And we've had some issues before, like ZDI had a few blog posts on it, where in a lot of applications, an assert is only really used in a debugging context, like in debug builds. In production builds, those aren't really used. So I'm guessing in HyperKit or in Beehive the asserts are legitimately in production builds, because otherwise these wouldn't even really be relevant.
Yeah, it varies. I mean, there's plenty of applications that do that where they'll write plenty of tests as asserts. That way they can just compile them out. That said, it is reasonably common also that asserts will be left in. It's a mixed bag. I wouldn't say things always go one way or the other, or usually.
Yeah, but it's just one thing to call out where, like, if you see an assert like that in an application actually being used as a security check, it's
It
just
is
kind of
worth
like,
making sure it's actually there when they compile in, yeah.
yeah, and it on top of that, like, it just seems really weird to do that because it's so ambiguous as to whether or not that code actually exists in production. So I don't really get the idea of using asserts like that
It's
as security
ambiguous.
checks, but
It's ambiguous to somebody who's just coming into the code base. If you know how the code's built, it's not really ambiguous at all. They either know how asserts are being used or they don't.
I'd say it's a bit of a code smell though, just because it kind of indicates that those were just ripped from um, potential like unit tests or something, and there's not like a properly fleshed out check. So I think it's just something to keep an eye on. That's all.
I kind of disagree actually. I think it isn't a bad, so this is a debatable thing for sure, and I haven't put a ton of thought into it, but I want to say it's Elixir that has kind of the crash first methodology. It might be another language, but the idea of crash first, crash often, just you enter an unexpected state, crash the program. Don't air handle, don't do anything, just crash the program, start over, and get back to a known good state rather than trying to do all that recovery. That's kind of what like keeping the asserts in is generally going to do. It's going to assert that, it's going to kill things off if these asserts fail. It's not going to bother trying to fix it up. And I think that is a fair perspective to take, especially if you combine that with the fuzz testing. So you're handling a lot of incoming things and you write these asserts kind of in the deeper layers to be like, you hit here, this has got to be right. Or something's gone very wrong, assert and crash and die. I think there's a fair reason to do that. I don't see it as a code smell. I tend to just look at it as, their coding style as kind of a decision equal to that. It's just another opinion on how to approach it.
Linus would be very unhappy with that take. For those not aware, the mantra of the Linux kernel and Linus in general is only crash if you absolutely need to. He absolutely hates like bug checks and stuff. So, and I kind of fall into that category as well. I think you should be doing proper error handling and not just crashing the moment you see something that is user controlled that doesn't look the way you want it to. Because it's really lazy and it's really like terrible for the user experience.
But it is valid, it doesn't need to be
if you're trying to prevent mem corruption.
It doesn't need to be terrible for the user experience. So I'll preface this, Elixir or whatever language I am thinking of, if it's not Elixir, isn't really a kernel language. It's not something where you're running, with the same sort of uptime expectation. I mean, you've got like crashing programs is a valid thing. Chaos Monkey with Netflix engineering team years ago kind of introduced the idea of like having something there that literally just kills your software in production. So it gets restarted and everything is built to handle failures.
I think Instagram does that too.
Yeah, I mean, I think that is a valid choice to make here. I think I feel like that can obviously denial of service being a larger risk, easily being able to crash a service with, say, a single request. But there are like the security considerations to be had there too, where you're not getting into these really weird states that often do lead to exploitable bugs.
Yeah, so the kernel is kind of like a special outlier, I guess, where the uptime is of utmost importance, because if the kernel crashes, your server dies. So it's a lot more of a problem. But
yeah, and it's worth.
Although in the context of a hypervisor, that's also somewhat true, right? Like we are talking about a hypervisor. So
yeah, I was just going to say it is worth remembering here that we are talking about a hypervisor.
Yeah,
which does have that sort of requirement.
But ultimately, like for me, that crash on failure just speaks of like lazy design. So personally, I don't like it. But like you said, that's kind of an ongoing debate. It's not something that's going to be universally agreed upon anytime soon. So yeah. That said, that is all of our hard topics for this episode. Z, I know you have a shout out, so I'll let you get to that, and then we'll move to wrapping it up.
Yeah, I just had one shout out here. It's actually related to the first vulnerability we talked about, the Open5GS vulnerability. At least I assume it is. Came out right around the same time from NCC Group, same author. Basically talking about the challenges of fuzzing 5G protocols. Basically just looks at some of the tooling, and some of the options that they took to get tooling up. I thought it was a somewhat interesting overview, giving a lot more insight into the background towards finding a bug, their whole test environment and stuff, especially for 5G. I don't see a lot of information kind of floating out about that in a lot of places, so I figured it was worth at least giving him a shout out here.
All right. So that's everything we have for this episode. Again, kind of like yesterday, a little bit short. Just wasn't a ton of topics earlier in the week. There has been some stuff that came out like yesterday and today, but that was pushing it a little bit too close. So we'll cover those next week. But yeah, thanks to everyone who tuned into this episode. The VOD will be on YouTube at 8 p.m. Eastern on Wednesday, or you can catch it on Twitch immediately. We also have previous podcasts up on Spotify, Apple Podcasts, and more links on Anchor. Feel free to join our Discord. I'll leave that link in chat. It'll also be below the video. And also follow us on Twitter. There we'll have announcements for whenever we're going live or any other content we put out. And like I said earlier, in Discord, we have some cool discussions as well. So, yep, links are down below or in chat if you are interested in that. We'll be back next Monday for our Bounty episode at 3 p.m. Eastern, 12 p.m. Pacific, and next Tuesday for another Binary episode at the same time as today, 7 p.m. Eastern, 4 p.m. Pacific. And we'll see you all next week.